Today we're going to go through some examples for the distributive property. And again, I'm going to do the same thing that I did before, where I'm just solving some example problems that are embedded in your homework. Okay, so the first problem is the instructions are to name the axiom or principle that justifies each step. And I'm going to solve this problem 5 here, where we have 3m plus quantity 8 plus 6m equals 3m plus quantity 6m plus 8. So to go from the left side to the right side, what we did was swap this 8 and 6m. And when we swap things, the order of things like that, we're applying the commutative axiom of addition. Okay? And now to go to the next line, where we have now quantity 3m plus 6m plus 8, we just moved these parentheses here to be around the 3m and the 6m. And when we change the grouping of terms that we have, then we're doing the associative axiom of addition. Now to get to the next line, where we have quantity 3 plus 6 times m plus 8, we've factored out this m, right? Both the 3 and the 6 were multiplied by m, and now we've just moved it to be outside of the parentheses. When we do that, we're applying the distributive axiom. And now to get to the next line, where we have 9m plus 8, we've just added the things that are in this parentheses, right? We took the 3 plus 6 and got 9 multiplied with m. And when we do that, we're applying the substitution principle. Okay, let's do another problem. So this asks us, these instructions ask us to simplify. And I'm going to do number 18 here. So when I look at this, I can see that I have two terms, this 23d squared and this 17d squared, two terms where I have a number times d squared. So that means that I can simplify that so that I end up with just one term where I have some number times d squared. So the way that I would do that is I would say this is going to be like 23d squared. Actually, let me do this slightly differently. This is going to be like 17d squared plus 23d squared plus 8. Here I've applied the commutative property, right? I just moved this 17d squared over to here. Like, I swapped the 17d squared and the quantity 23d squared plus 8. Okay? This is going to be the same as 17d squared plus 23d squared plus 8. There I applied the associative property. This is going to be the same as 17 plus 23d squared plus 8. There I applied the distributive property to factor out the d squared, which is common to both these two terms. And then I have 40d squared plus 8. And that's as simplified as I can get because I can't combine two terms that, where I've got a d squared and there's no d squared here. So I can't combine those two terms. So I'm going to box this as my answer. All right, let's do another one. So this is also asking us to simplify. And I'm going to do number 20 here. Whoops. I'm going to do number 20, which has d to the fourth, and those can be combined together. It has 2d to the fourths, and it has 1d squared, which cannot be combined with those. So this is going to be the same as 16d to the fourth plus 9d to the fourth plus 8d squared, where I just applied the commutative property on these two terms. Now this will be the same as 16d to the fourth plus 9d to the fourth plus 8d squared, right? I'm just associating these two terms together. And then I can apply the distributive property and factor out this common term. So this will be 16 plus 9, d to the fourth plus 8d squared. That's using the distributive property. And that's going to be 25d to the fourth plus 8d squared, where I'm applying the substitution principle, right? 16 plus 9 is the same as 25. So when I substitute in the 25 for 16 plus 9, it's the substitution principle. And that's as simplified as we can get. That's the final answer. All right. Let's do another example. I'm going to look at number 31 here. So here I have two terms that have a common factor of a. And in order to simplify this, I need to combine those a's together. And I also have two constants here, right? There's no variable there, so I'm going to call them constants. I have two of those, and those can also be combined because I can always add numbers together. It's when I have variables that I can't combine them unless they are like terms, meaning, like a and a are like terms. But if I had this as a squared, that's no longer a like term with a because it's, two of them there. Okay. So the first thing that I'm going to do is distribute this 4 to both of these terms in the parentheses using the distributive property. So that's going to give me 4 times 3a plus 4 times 5. And then instead of, carrying around this 8a plus 1 term the way that it's written, I'm going to do the exact same thing, where it's 8 distribute out to the a and distribute out to the 1. So this will be 8a plus 8 times 1. Now I can swap these two terms using the commutative property. So this will be 12 times a, where I, use the substitution principle to replace the 4 times 3 with 12. 12a plus 8a plus 20, right? 4 times 5 is 20, so I can replace that with the substitution principle. Plus 8 times 1 is just going to be 8, again with the substitution principle. And then, I can associate these two together and these two together. And then I can factor this common a out so that I wind up with 12 plus 8 times a plus 28. Now I can apply the substitution principle again to the 12 and the 8, and that's going to give me 20a plus 28. And that's my final answer. Okay. Let's do another example. We're going to do this number 46 here. So here I have two terms that have n squared. Those are going to get combined together. I have just one term with n, so there's nothing that I'm going to be able to combine that with. And then I've got some integers here. And those will get combined. Okay, I'm going to take the same strategy that I took before, where I first distribute out my factors here. So this is going to give me 6 times n squared plus 6 times 2. And then when I do the next one, I'll have 2 times 3n plus 2 times 1. And then I've still got this 9n squared. Okay. Now, using the commutative property, I can move this 9n squared to the front here, right? I could imagine that I've got, parentheses around this, and so I can move this out to the front, and then I can associate my 9n squared with my 6n squared like we've been doing. So we're just going to imagine that, because I'm not going to carry out all those steps painstakingly. But we would wind up with 9 times n squared, which I'm just going to write as 9n squared plus 6n squared plus 12, where I've substituted 12 for 6 times 2, plus 6n, because that's, 2 times 3 give me 6, and then plus 2. So to simplify this further, I'm going to apply the distributive property to this, right? Each of these terms has a common n squared that I can pull out. So this will be 9 plus 6 n squared. And then I can combine my 12 and 2. So that's going to give me 14, and then I still have this 6n. Now I just need to substitute in 15 for n squared for the 9 plus 6, so I get 15n squared plus 6n plus 14, and that's going to be my final answer. Okay, it's pretty common when you have terms that have a variable that is, taken where you have, various powers of a variable, to write the highest power as the first term and then go down. So, n squared is going to be the highest power of n that we have in our expression, and so that's going to be the first one that we would write. And then n is the next highest power, so that's going to be the next one. And then something that's, kind of fun to think about is that this 14 term is actually like 14 times n to the 0, right? Because anything to the 0 is going to be 1. Okay. So now we're going to do another problem. And the instructions here are write a variable expression for each word phrase, then simplify the variable expression. So I'm going to do number 50. And here it says, twice the sum when a number b is added to a number a, increased by 3 times the sum when twice b is added to a. So I have twice the sum when a number b is added to a number a, that's going to correspond to a plus b, that's the sum, and I've got twice that sum. And then it says increased by 3 times the sum when twice b is added to a. So now I've got a new sum of twice b added to a, and it's going to be 3 times that. Okay, so that's my variable expression for the word phrase, and then I just simplify. So I'm going to want to combine terms that have a factor of a together, and then I'm going to want to combine terms that have a factor of b together. So I will apply the distributive property to both of these two terms here, and I'll get 2a plus 2b plus 6b plus 3a. And then I'm going to want to combine these two terms together. That'll be 5a. And then I'll want to combine these two terms together, and that'll be 8b. So here we've, skipped a lot of the painstaking steps where, 2a plus 3a would get combined as 2 plus 3 times a to give me 5a. Okay, so this is my final answer here. And this is also part of my answer because it was asking me to write a variable expression for each word phrase. Okay, we're going to do one final example. So this is asking us to simplify. And we're going to take a look at number 61 here, which looks really massive. But we're just going to take it step by step. And when we do that, it won't be too bad. So what we can see is that we've got a lot of terms with p squared. And then we've also got a lot of terms with p. And we've got a lot of terms that are just integers here. So the terms with p squareds are going to need to get combined together. The terms with p are going to get combined together. And then the integers are also going to get combined together. And I'm going to start by looking at this first grouped term here and trying to simplify that. So that's going to be 4 times 3p squared plus, and then I'm going to apply the distributive property here to distribute this 2 out to each of these terms, plus 2p squared plus 4p plus 2. Now I'm going to do the same thing with this term here. So that'll be 3 times 2 plus, I'll distribute this 3 out to all of my terms with the distributive property, 9p squared plus 3p plus 6. And then finally, I'm going to do the same thing here where I distribute this 2 out to each of these terms. So that'll be 2p squared plus 2p plus 1. Okay? Now, I'm going to do one thing which simplifies the expression here in parentheses, which is combine these two p squareds, or the two terms that have p squared in them. So this 3p squared plus 2p squared is just 5p squared. So I'm going to write it that way. And then over here on the right, I'm going to combine my 2 and my 6 because those are also like terms. So that's going to give me plus 8. And then now I can distribute out my 4 to all the terms in the parentheses here, and my 3 to the terms in parentheses here, and then I can add. Okay, so this is going to be 20p squared, right? 4 times 5 gave me the 20, plus 16p, 4 times 4 gave me the 16, plus 8. So that's it for, for this term that's over here. Now we're going to look at the one over here. So that's going to be plus 27p squared, 9 times 3, plus 9p plus 24, because that's 3 times 8. And then I've still got my other terms here, 2p squared plus 2p plus 1. Okay. So now, instead of doing this incredibly painstakingly, I'm just going to circle all my terms that have a p squared in them. And those are the first set of terms that I'm going to combine, right? And I'm just going to add the integer factor that's in front of the p squared terms. So 20 plus 27, 47, plus 2 gives me 49p squared. Now I'm going to do the same thing for my p terms. I've got 16p, 9p, 2p. So 16 plus 9 plus 2 is going to be 27, right? 16 and 9 give me 25, plus another 2 gives me 27, 27p. Finally, I'm going to do the same thing for all the integers that I have, 8, 24, and 1. 8 plus 24 is 32, plus 1 gives me 33. And this is my final simplified answer, right? I could have, painstakingly applied the commutative property, the associative property, and the distributive property. And if you were confused by any of these steps, then I encourage you to do that yourself. All right, that's it for today.